Hi everyone. So this is going to be the third video in this Catalan numbers series. We started in the first video by coming up with a recurrence relation for the Catalan numbers. And remember, the Catalan numbers count a lot of different sequences of objects. The numbers are always the same, but they might arise differently in different contexts. The one we were looking at is that we were multiplying just any n numbers together and counting the number of ways that you could actually pull that off. That's how we defined the Catalan numbers. And there was one important thing I should mention, namely that we were assuming that those n numbers were left in their position and weren't like shifted around from the first to the second position or what have you. So when we counted the number of ways to parenthesize or multiply those n numbers together, we came up with that the number of ways to multiply one number together is 1, and that's true for the number of ways to multiply two numbers together as well. And then we came up with a general recurrence relation for n beyond 3. Okay, and the way we thought about that was just basically parenthesizing like the first element and then the last n minus 1, or the first two and the last n minus 2, and then thinking about how to break down those subproblems. So that's where that recurrence relation came from. Then in the second video, we constructed the generating function for the Catalan numbers here. Now, one thing to notice is that the constant term is 0 for this thing. And we recognized that eventually, if we square the generating function, you get this. But the interesting thing about this is that, for instance, the thing sitting next to x4 in this case, that complicated looking thing is really just the recurrence relation for C4. And so this whole thing simplifies down to the Catalan generating function again, almost. It's missing its first term. So that's why you have this C of x minus x here. So overall, we ended up with, I don't know if you remember this or not from the last video, but we ended with a cliffhanger last time, namely that the square of the Catalan generating function is equal to the Catalan generating function minus x. Okay? Okay, that was the big surprise at the end of last time. Okay, and it turns out everything else about trying to find a formula for the Catalan numbers comes directly from that identity right there. And the question that we're going to seek to answer in this video specifically is, what is the generating function? It's not enough to just write down this formula that it satisfies. We really want to know what it is. Like, what's the formula for the Catalan generating function? And once we have that formula, we'll be able to extract from it the coefficient of x to the n, kind of like what we've done with other generating functions, and we'll have our formula for the nth Catalan number. Okay? So let's play with this formula right here a little bit and see what happens. Okay? So I'm going to go ahead and erase all this junk up here, and then we'll start working with that. Okay? So here we go. All right, so we already know that the square of the Catalan generating function is equal to the Catalan generating function minus x. Okay, so that's kind of our starting point. And by the way, at this point, the recurrence relation and everything isn't really needed anymore. All of that information is embedded inside of that one singular identity. Everything that we knew about the Catalan numbers and the recurrence relation is actually captured by that formula right there. So that's why it doesn't really matter that I just erased a whole bunch of information. Or even if you don't know anything about the Catalan numbers at this point, uh, that is an identity that this function satisfies. And even if you didn't know it had anything to do with Catalan numbers, you could stare at this and come up with a formula for that function based on what we're about to do. But all of the information about the Catalan numbers is captured by this identity. Okay, so let's go ahead and take this thing and mess with it a little bit. Okay? All right. So this has the form y squared is equal to y minus x, where y is basically the Catalan generating function. Yes? So let's think about that a little bit. I want to solve for y. I want a formula for the Catalan generating function. That's what I'm calling y here, just for simplicity. How are we going to do it? Well, maybe we should put everything on one side of the equation or something. Okay, so watch. Y squared minus y plus x equals 0. All right? And what we do is we say, if this were like at squared plus bt plus c equals 0, I think I would know what to do. I would be able to solve for t, yeah? T would be negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, just the standard quadratic formula. So here you can see that y is kind of playing the role of t, that a is played by 1, b is played by minus 1, and c is played by x. It's a little strange, but nonetheless, I could still use the quadratic formula to write down what y actually is. Okay, so what is y? Well, y is going to be equal to negative b, so 1 plus or minus the square root of b squared, which is 1, minus 4 times 1 times x. Yeah? Minus 4 times 1 times x, right? So it's going to be 1 minus 4x, yes? All over 2 times 1. Okay? So there it is. So that's interesting. That means we've basically solved for y, i.e. c of x. Okay, so we know what the Catalan number formula actually, or the Catalan generating function formula actually is at this point. It's going to, so c of x is going to be 1/2 plus or minus 1/2 times the square root of 1 minus 4x. Okay, there it is right there. But is it plus or is it minus, right? That is the question. Is it plus or is it minus? Well, we can actually sort that out because you know what the Catalan number generating function evaluates to at 0. Remember, the Catalan number generating function didn't have a constant term. So everything had an x attached to it. So if I plug in x equal to 0, I should get 0. Okay? So you know that 0 equals c of 0. And which of these is it going to be? If I plug in x equal to 0, if I took plus, I would get 1. Do you see that? If I took the positive one, I would get 1. So that's no good. I want to get 0. So that means I need to take the minus and not the plus. Okay, so this is equal to, 1/2 minus 1/2, not 1/2 plus 1/2. So what does that tell us? Well, that's the punchline. That tells us, so this implies that c of x is actually 1/2 minus 1/2 times this square root 1 minus 4x. Okay, so there it is. We actually just came up with a formula for the Catalan number generating function. Okay, and that's fairly amazing because it doesn't look like anything that we've seen before. Everything we've seen before has been like, a binomial raised to an integer power, like the donut function, etc. In this case, we actually have 1 minus 4x, and that thing is being raised to a fractional power 1/2. So in the next video, what we'll do is we'll think about what to do with this thing right here to make it useful for us. We're going to need to figure out what to do if I have a binomial with a fractional power, and it turns out it's actually not that hard to deal with. We're going to exactly be able to figure out how this thing expands as a generating function, similar to what we did for other binomial type generating functions, and like the donut function, for instance. So we're very close to actually solving the Catalan recurrence relation based on having this formula in hand. Okay? All right, I'm going to stop right there for now, but this is kind of a nice little formula to have in hand, and we'll make good use of it later on. Bye for now.